Hi, I'm Jesús Espino. I'm a software engineer at Mattermost, and I'm going to talk about observability and measurement in active environments, or how we raise and maintain our performance. Well, first of all, a bit of history. What is Mattermost? Mattermost is a messaging platform very focused on security and performance. It's open source and feature rich. How it started Mattermost? In the early stage, we was writing in Python, but we moved into Go pretty quick, and we bet strongly in SQL databases using Postgre and MySQL. Where the focus at the beginning was making the features work, making it secure, gaining some. We gain a lot of performance from the election of the language using Go. There's a lot of performance gain compared to Python, and we started with the usual low-hanging fruits with databases like creating an index here and there, tuning this query a bit, tuning this other query a bit, and we had some monitoring and telemetry since beginning. But and all that take us very far. But well, you reach a point where you have to measure and you have to monitor your system to be able to keep scaling up. And because the complexity of the platform goes up, and you can't scale up with this low-hanging fruit. For that, we use different tools. For monitoring, we use Prometheus and Grafana, and for telemetry, we use Radar. Why we selected these tools? We selected these tools because they are open source, and we love open source, and they are high quality battle tested projects. So there's a lot of projects using Prometheus, Grafana, and Radar that are really successful, and for us is a secure bet. So telemetry. We have telemetry to know what our users are using. The telemetry is sent to Mattermost Inc., the company, and we track the features, the different normally settings that are not are if the settings are in the default value or not. That gives us an idea of how the people is using Mattermost without giving us private information. All our telemetry is anonymous. We don't know. We are not able to track what server is from what user or things like that. We are just tracking that there are servers that have certain features on. There are other servers that have other features on, and with that information, we can decide what our users are doing, what our users prefer, and this way we can focus our efforts in improving that features, in basically deciding what's more important performance-wise. About monitoring, we use Prometheus to track the performance and system-related information. We have a lot of information about caches, about database connection, about the times that the database takes, the times that the API calls take, the number of Go routines, CPU utilization, memory utilization. A lot of data is collected and is sent to a Prometheus. This data is not sent to Mattermost, the company. It's sent to a Prometheus and in the user infrastructure. So you have your own Mattermost instance, and this information is sent to your own Prometheus instance. But we leverage this information in our own instances. Mattermost is a heavy user of Mattermost itself. So we have our own community server where us and the community can talk. And this server is a very good place to extract this data and understand how the performance is going. How we instrumented our code for monitoring. We have followed three different paths here. One is the simplest solution, that just add the instrumentation code where it's needed. For example, if we want to measure the cache hits and cache miss rates, we just, whenever we access to a cache, we add a hit, and when we access, when we miss accessing to the cache, we add a miss. That is the simplest approach. Then we have other approach that is related to other places where it's generic enough to use Go generate. We leverage two different tools from Go for this. We use Go generate and struct embedding. We define an interface, then we auto-generate code for that interface, auto-generate an implementation of that interface, and that implementation embeds the real implementation. And this interface, this generated code acts as a wrapper around the real implementation that instruments our code. In this case, for example, we have the store, the database store, which is our abstraction to the database access. And that store have a set of methods, and every method is wrapped with this auto-generated code and adds and measure the time that takes to execute that method and set that information to a Prometheus. Here is an example of this kind of instrumentation. Basically, this code is automatically generated, and for every single method in our store interface is going to get the time, execute the underneath method, the real implementation, the SQL store implementation, measure the time again for get the time again for compare with the already stored time, and store that information in Prometheus. So this way we know how much time it takes to execute any method in our store without the SQL code knowing anything about the instrumentation. So we don't contaminate our code. We don't need to maintain this code. We only need to maintain the generator code and the template that we create for this generator. And it's a really good way to not contaminate the rest of the code. The other way that we instrument code in Mattermost, because Mattermost is a REST API from the server-side perspective, we just create we have an entry point that every single request in Mattermost is going to enter through this point. And we just store the time there, verify if there was an error or not, and add the counter to Prometheus, and verify if we are not asking for the WebSockets, because it makes no sense to measure the time of the WebSocket API connection, and store in Prometheus how much time it takes to execute the handler that was requested. And that's it. This way we have all our API instrumented in one single place, and we know how much time it takes to execute any single handler from the API. And this is the result. The cool thing about all this is you can have a lot of information. This is just some examples, some simple examples around the data that is collected, but you can have, we have actually a lot of other graphs and a lot of other statistics. This is, for example, in this case, we are seeing the top DB queries by count and the top DB queries by time taken. That is not the same, because sometimes a query can take a tiny amount of time, but a lot can be executed a lot of time, so it can be very time consuming, but only executed time to time, things like that. Other cool thing that is not that is provided directly by Prometheus and Grafana is this information is kind of real time information. You get information every 5 seconds, 15 seconds. It depends on your configuration from Prometheus. And this information is shown here in real time. So you are seeing things, you can filter in real time, you can get ranges of time because Prometheus have a time series database. So you can query about a certain range of time and see how it and see information in that range. You have a lot of power here to analyze and decide what is a performance degradation, what is a bottleneck. All that information is really easy to extract from these graphs. These specific graphs are from our community.mattermost.com server. So we have a lot of information there. Well, but the problem that we have here is Mattermost is a heavy user of Mattermost itself, but it's not the heaviest user of Mattermost. We have a lot of users that have way more load than us. We have, for example, there are Mattermost instances with more than 50,000 users. That requires a lot of scalability. That requires a lot of testing to verify that everything is working at that scale. And for that, we have our load testing suite. There is a lot of load testing suites out there, like JMeter and things like that. We are not using them. We are using a homemade solution. We decided to make our own load testing tool right in Go. That is our language of choice. So we really love Go. We have a lot of Go tools in Mattermost, not only the Mattermost server. And we decided to write our own tool. We used Terraform to deploy everything and set up the cluster for executing the load test. And we host that cluster in AWS, but probably we could just using Terraform, we could deploy that in other service provider. But we are using AWS for now. Well, we started creating a load test that was focused on generating load based on parameters. We decide to how many users do you want to support, how many posts per second, how many, a lot of information there around how you want to create the load test. Was really hard to configure, but was really good verifying that a system can support up to X user. So that was our first try. We decided that we can do better. So we try it again, and the new load test is more focused on generating realistic data. We decide what is realistic data, what is how much load is generated by a user. The good thing about this is it's really easy to configure, and how it works. Well, it's gradually increase the load until it hits certain threshold, and when it hits a threshold, it starts to decrease the number of users and increase again and decrease again and increase again until reach certain stability. And this load test is really good for figuring out how many users you can support in a system. You can run this in a Raspberry Pi and execute the load test. You can run this in a super huge cluster and run your load test. It's going to give you different numbers, but it's going to work in the same way. Well, how it works? It uses Terraform to create certain instances and EC2 instances and RDS instances in AWS. Mattermost itself and the load test is deployed in different EC machines. Start running the load test, and after a certain time, the system start to reply to the request, surpassing this threshold that is what we consider no longer optimal instance. So if we surpass that threshold, we reduce the number of users and we increase that again and all that stuff. When it finished, we collect all the data generated, and with that data generated, we can figure it out if that performance, if the performance is increased or is decreased, and let's see how is the results. This is one part of the results. The result is going to give us a Grafana dashboard with all the data that we've seen before and much more. About these multiple servers, normally we create a comparison between two versions because what we need is a baseline and another version that is the version that you want to verify if has been improved or have been degraded. In this case, there is a tiny degradation in the performance. We decrease from 2,991 to 2,933 users support, but we expected that decrease in this version because we introduced a new feature that implies some performance degradation, and we expected that. Normally we increase that number, but in this case, in this example, is a decrease. And this is the other part of the results. Apart from all the statistics from the Grafana, we have these graphs where we have the API times, the store times, the number of coroutines, the number of requests per second, the heap usage, all that information is here. So we can compare the two branches or the two versions of Mattermost, and we can decide if we are increasing or decreasing the performance. Well, when you have that, we have already a way to verify that our performance is. We have a way to get the performance information, the monitoring information. We have a way to generate load, so we can figure it out pretty well when something goes wrong. But it's not so easy to know what goes wrong. Actually, 99% or 95% of the time, it's pretty easy to know what is going wrong. You normally see, okay, this store method is taking too much time. This SQL query is too slow. We have to improve that some way. That is most of the time it's easy to figure out where is the problem. Solving the problem is not that easy, but finding the problem is easy. For the other 5% of the time, we need to debug that. We need to verify where is our performance going. So for that, we have these three tools. We have open tracing, we have Jagger for visualizing the open tracing information, and we have pprof. This is for fine-grained performance debugging. As I said, sometimes it's not so easy to know what is happening or where is the performance going. So open tracing provides us a very good fine-grained performance information, and pprof help us to figure out what is the state of the system in certain circumstances. Open tracing instrumentation. For the open tracing instrumentation, we follow the same approach that we mentioned before, using this struct embedding plus Go generators. So we create a set of wrappers around our main parts of the application, and this way we have tracked almost everything from everything that happened in a request. Not everything is instrumented this way. For example, the API is instrumented using a similar approach that the one that was exposed before for the monitoring. And not everything is instrumented. Some parts of the code are not instrumented because we haven't seen the need yet, and it includes some burden of generating these generators, maintaining these generators, and all that stuff. Well, here's an example of auto-generated open tracing code. Basically, it's the same approach. We have a SQL database or SQL store under the hood, and we create the context for open tracing. We populate that context with information, with tracing information. We call the underneath method, and we return the result. But the interesting part is this part. Once you have everything instrumented in your application, you can access this Jagger UI, where you can go there and see the requests that are happening. You have to enable open tracing because open tracing is not cheap. So we need to enable and disable it when we need to track that information. But we track, we create this, we enable open tracing, and we enable open tracing, and we go to this, we create the request that we want to measure, and we go to the Jagger interface, and we can see this information here. If this information, if you need to optimize this request, you can see where the time is going and what is the place that the performance is more impacted. So, for example, in this case, if I have to investigate how to improve the performance of this API, of this call, I will start with the post store save because it's the one that is taking more time. Maybe it's not there the problem, but probably if I can improve that, probably I'm going to improve a lot the whole request. This is how we use open tracing for performance investigation. And pprof instrumentation. Okay, well, pprof comes with Golang. Is super interesting tool. Support easily exposing the pprof information, use HTTP, and give a lot of information of the running application. Here's an example. This is not from the Mattermost source code because it's just way simpler to show this. For example, well, in this case, I imported pprof. That is going to automatically register the handler for accessing pprof, and just listen and serve in a port in my machine. Then I can, for example, in this case, execute curl and get information from pprof. Normally, what I'm going to do is just use go to pprof and the API endpoint and go to the different places, like getting information about the heap, getting information about the coroutines, and I can investigate it more. In this case, I'm seeing all the coroutines that are executing in my binary. In this case, 147, and where is each coroutine in the execution? What files and what point is executing the coroutine? That is very useful when you have deadlocks and things like that, and you need to know what is going on with the coroutines. It's pretty interesting. Other tools that we use is, for example, Delph, that is the Go debugger, Go benchmark. We normally try to address we don't need to improve the performance of Go that much because most of our bottlenecks are in the database layer. But sometimes we need to improve the performance in certain places because they are used a lot. And for example, in this case, lately we have an improvement in the cache serialization mechanism, And we used Go benchmark to do micro benchmarks around the serialization code to decide what serialization mechanism we are going to use, and to compare with the current mechanism and see if we are getting more memory, or we are getting more CPU or less, or how it's behaving. So Go benchmark for micro benchmarks around small pieces of our Go code works pretty well for us. Logging, we use logging a lot. So this is a great tool for not only for performance, but can help in performance investigation too. All the database provided tools, the usual suspects like the query plan analyzer, the log, the slow queries, all that stuff. Also, we have tracing for SQL, for LDAP, for Elasticsearch, so we can see what is exactly going on with the database or with our Elasticsearch, what information is sent, and all that stuff to know exactly what is going on. Well, everybody in the company has his own tricks and his own tools that they use, and maybe others not. But well, I think most of the most interesting tools are here. And well, if you want to go deep with all these subjects, we have a lot of blog posting in the Mattermost blogs that are really interesting. We really like to share what we are doing here and on how we did the things. And for example, the blog post improving performance through load testing, explain our load testing suite and how it works, monitoring the Mattermost server with Prometheus and Grafana, give you give you an introduction about our thinking around Prometheus, Grafana, and how monitoring should work. Open tracing for Go projects is how we implemented open tracing. Later, the store using a struct embedding in Go. This is the approach that we have followed for this combination of generators and struct embedding. And instrumenting Go code with via AST is more or less the same. It's around this Go generate to generate these layers and these structures. Well, the Mattermost blog is full of a lot of interesting information, and I think if you want to understand better how Mattermost works under the hood, is a very good place. If I have to finish with one single thing, one single thought, I will say you measure as much as you can, because be able to measure, reproduce, and trace performance converts your hunches in demonstrable certainties. And that is great, because hunches works pretty well at the beginning when the system is not so complex, when you can have the whole context in your head. But when the system get complex, that hunches are not so reliable, and you have to deploy to production, you have to do things, and the behavior at a scale is not what you expect normally. The query planner start to do weird things that you don't expect. The queries are starting to get complex, all that stuff. So if you are able to measure, reproduce, and trace, you are going to save a lot of time and a lot of headaches. And that's it. Thank you.